Dear students, in this video we are bringing you one more competitive type question. All the students of 8th grade, 9th grade, 10th grade can of course follow this. It is very important problem. Find the value of summation of I upon 2 to the power I minus 1 from I is equal to 1 to infinity. Let's see how we find the solution to this. You will come across such questions in competitive examinations if you are seriously preparing for Olympiads, KVPY, NTSE, KTSE examinations. Definitely you must focus on such problems. You will always get videos of this kind of problems. I always lift difficult problems so that it will be useful for this kind of category students also. In fact, even normal students can start understanding these problems so that one can improve upon mathematics. It is very necessary, I feel, and hence everyone should watch such kind of videos. Please forward these videos to others, your friends, your relatives, so that it will be helpful for others. It's a free channel. You are not paying any fees for this. Let's look into this problem. Since it is summation here, we will call it as let S is equal to summation of I upon 2 to the power I minus 1, where I is equal to 1 to infinity. Now, S is equal to, I'll elaborate it. I is equal to 1 to infinity. Therefore, I can assume the value of 1, 2, 3, 4, 5 and so on. Therefore, I'll elaborate it. 1 upon 2 to the power 1 minus 1 plus 2 upon, because now I is equal to 1 I have taken and I is equal to 1 I have taken. Next I have to take 1 to infinity. 1 to infinity means I can take 2, 3, 4 and so on. I values goes on changing. I is equal to 1, 2, 3, 4, something like that. Now it becomes 2 to the power 2 minus 1. Next it becomes 3 upon 2 to the power 3 minus 1 and so on. Next becomes 4 divided by 2 to the power 4 minus 1 and so on. Very great. This is equal to. Now it can be simplified as 1 upon 2 to the power 0 plus 2 upon 2 to the power 1 plus 3 upon 2 to the power 2 plus dash dash dash. Very fantastic. This is equal to. We write it as 2 to the power 0 means 1. Any number to the power 0 is equal to 1. And hence we write this becomes 1. 1 divided by 1 is equal to 1. Plus this becomes 2 divided by 2. For the purpose of further calculations, I'll keep it as it is for you. We will just see. And this is plus 3 upon 2 to the power 2 plus 4 upon 2 to the power 3 and so on. I have not written here, but I have written here for the sake of understanding, because the series goes on like this: 1 plus 2 by 2, 3 by 2 square, 4 by 2 cube and 5 by 2 to the power 4 and so on. Now S is equal to so much has come. Let us now calculate. Multiply this by 2, that is half S, that is equal to. Each term has to be multiplied by half and have to be written properly under one another. Half into 1 is equal to half. Therefore, I will write it in 1 by 2. Because it is 2 by 2 here, I will write here 1 by 2. And next, 1 by 2 and 2 by 2 multiplied, it becomes 2 by 2 square. Now I am writing, why I am writing, base here denominator is 2, here is 2. It is 2 square, it becomes 2 square here. That's why I am writing it like this. Keeping this place aside, I'll keep it blank here. Plus 1 by 2 into 3 by 2 square means it becomes 3 by 2 to the power cube and so on. Now I want, this is S and this is half S. S minus half S. We will deduct each term in this. 1 minus 0. Nothing has come here. Therefore, I will keep it 1. 2 by 2 minus 1 by 2. 2 by 2 minus 1 by 2. Here it is 3 by 2 square minus 2 by 2 square and so on. This becomes 1 plus 2 by 2 minus 1 by 2 means 1 by 2 plus 3 minus 2 means 1 upon 2 square. Now 1 plus 1 upon 2 plus 1 upon 2 square plus 1 upon 2 cube, the series will become. S minus half S means actually half S. Very good. Now 1 plus 1 by 2 plus 1 by 2 square, 1 by 2 cube, all these are, it is actually forming a geometric series. In a geometric series, you have first term is A. This is, we will write it as here A is equal to 1 and the common ratio. In case of AP, we find the common difference, and in case of geometric progression, we call it as a common ratio. 1 by 2 divided by 1, that becomes R is equal to, common ratio is equal to 1 by R. Sorry, 1 by 2. R is equal to 1 by 2. Now, half S is equal to sum of geometric progression to the infinity. That formula is A upon 1 minus R. A is nothing but 1. This becomes 1 minus R is nothing but 1 by 2. A little harder here because you will not be knowing sometimes what is geometric series. So you need to understand that. If you are familiar with the geometric progression, arithmetic progression and harmonic progressions, it will be very easy to understand. But however, the information given by me at this stage will be sufficient enough to understand. This is 1 plus 1 by 2 plus 1 by 2 square, 1 by 2 cube. What is remaining is the common ratio is remaining constant in each case. That is called as R equal to 1 by 2 and first term is A equal to 1. So having a background of arithmetic progression, you will be able to understand this quickly. Now, half S is equal to 1 upon 1 minus 1 by 2 means 1 by 2. It goes up, it becomes 2. And this 2 goes the other side, therefore S is equal to 4. And hence, the summation of I upon 2 to the power I minus 1 from I is equal to 1 to infinity becomes just, the final answer here becomes summation of I upon 2 to the power I minus 1 from I is equal to 1 to infinity is equal to 4. That's how the answer comes. It looks very, very big question before solution. And once answered, it becomes very easy. Wish you all the best. Enjoy yourself. And to receive such videos, please subscribe my YouTube channel. Our YouTube channel is quite simple one. It is COTA Maths Lab. Go to YouTube channel, search for it, subscribe it, get daily notification to receive such videos. Wish you happy learning.